Zhamak Dehghani, very happy that you could make it, very happy that you're here. Zhamak needs no introduction as well. She is well known with the data mesh. Just in 3 words, she studied computer science in Tehran and in Sydney. She moved to the States, and 2019 she talked for the first time about something which later became the data mesh, known as the data mesh. It was called Beyond the Data Lake, because already then, of course, people realized that the data lake itself will not be sufficient for whatever we want to do. Zhamak, thanks very much for joining us today and sharing your experience with you. Here is Zhamak with data mesh in action.
Thank you very much for the introduction. Thank you for hosting me. I am joining you bright and early from San Francisco as a giant head. So I'll try to go a little bit further back. So let me share my screen. We jump right into it. We do have quite a bit of time together, about 90 minutes, I believe. So I'll be presenting, if you are joining online and if you like to leave messages on the chat, I will keep an eye on the chat. And we will have about 30 minutes for Q&A, and I'm excited to hear your questions and concerns. So as it was mentioned publicly, I talked about data mesh in early 2019, and even during this short few years, a lot has happened. It went from a question as what is beyond data lake as the problems we saw, and it turned into one of the biggest movements in the data industry at the present time. So then your question might be, are we there yet? What is data mesh? Have we addressed all the concerns and the challenges? What challenges remain, and what should we do about them? So there's a fair bit to cover here. A quick introduction. I am a CEO and founder of a startup that is working on technology to make data mesh possible for everyone and accessible. I'm calling it data mesh operating system. There are 2 books here that I had contributed to last year. One is kind of a definite guide, I suppose, on data mesh. And the other one is looking at software architecture generally, and data and analytical data is part of it. And I have left 2 codes on the bottom of this screen if you want to take a photo of it. In case you want to get access to these books for free, those codes will get you to O'Reilly for about a month or so of free access to all of their books, including mine. Okay, why are we here and we talk about data mesh? Because we are really at an inflection point. The complexity of organizations, and one way of defining that is the number of sources from which, the number of places, the number of touch points from which we want to gather data and use that data to generate value, essentially, to either make automated decision-making or create applications that are personalizing their experience, or make recommendations and make futuristic kind of decisions. Then those numbers are growing. And the complexity of organizations are growing. And in fact, the previous paradigms of how we have thought about data generates value have broken. The complexity of organizations have broken them. And what do I mean by that they are broken? If you look at this chart, what I'm trying to show is as complexity of organizations grow, the approaches plateau in giving us business impact. They plateau in the ratio of value to cost. They plateau in moving fast as the number of, data-driven applications, the number of sources of data grow. They become more fragile in terms of managing change. So then data mesh is an approach that embraces organizational complexity as a fact. It accepts that data could be managed by different teams, by different organizations. We need to get value from data regardless of where it is and who owns it, beyond organizational boundaries. And it accepts that things constantly change. We need to be able to get value from a data that is constantly changing as part of the application lifecycle changing, the user behavior changing. And it accepts all of that and say, okay, what is the approach in managing and accessing data for analytics and ML that it can gets us to newer heights? A little bit of evidence in terms of this plateauing claim that I just made. I think there is industry evidence in terms of the market research, and this New Vantage Partners market research is something that I chase year to year and keep an eye on. It's a fantastic survey from executives across large number of organizations, and what it shows here is this proportionate amount of investment and attention to big data and AI, with 99% of organizations investing in, and with many of them, more than half of them investing more than $50 million. What we're seeing is pretty much limited results. Only 24% can claim that they're widely adopting data-driven solutions, whether it's applied ML or analytics in their business. About only half of them, they can compete using data. So those are disproportionate numbers when you think about the universal spending that's happening. And the reason for this plateauing is not that the technology we have is not great. I think we've done amazing progress when it comes to the technology. But the progress that we had made and we had to make was to optimize for the machines, optimize our solutions to respond to the large volume of the data, right? With MapReduce, Hadoop, distributed file systems, we had to build technology that optimizes for the machines be able to manage large volume of the data. We had to optimize technology so we can deal with the scale of diversity and variety of the data, with the object stores and time series databases and document databases and all of these different kinds of data storage to manage different types of data. We had to respond to scale of velocity of the data as mobile phones and real-time applications became more prolific and used. So we had to build the Kafkas and the pulsars and the streaming processing mode of analytics. What we haven't done in our attention and in our focus for the last few years is the organizational complexity, the scale of how many sources, how many places realistically we need to get access to data. Even for the smallest, simplest analytics, we need to access to many diverse sets of data, types of data coming from many different places, and the complexity of proliferation of use cases going beyond localized analytics and BI to applied machine learning model to every single touch points and application. This is what O'Reilly calls programming 2.0, moving away from writing programs that are based on logic to the programs that are based on patterns exploited within the data. So then why the plateau? Okay, it's great. We have made all these progress on managing the scale and velocity, but the reason we are not able to respond to organizational complexity is this set of assumptions. The assumption that to get value from data, it shall be centralized, and centralized organizationally and by the technology, that we have to get data from all of these applications and teams and sources that produce the data, put it in a team, a data AI team need to do that, the data engineers, put it in somewhere that we can get value. And then, as you can see in my comically displayed image here, that creates organizational bottleneck. The other challenge is that to manage this process of data on one hand, and let's say value from data from the other hand, we had come up with this pipeline model. I mean, data pipelines, it's such a common word in our language, but even at the macro level, we're having this pipeline model that we will get data from all these places, move them through some labyrinthic data pipelines and cleanse them, transform them, and load them into lakehouse, warehouse. And then we layer it, again, another step of the pipeline, we layer it with metadata, with access control to give access to the users, and pop, the other end comes the value, right? Machine learning model applied, trained, insights, knowledge, and so on. And this creates a long lead time from where the data is and changing to where the data is used, and we get meaning from it. And it's full of friction because we have created these fractional silos. I'll work on ingestion, you work on pipelines, somebody else works on data APIs. So this process is full of friction, and we're doing this at an organizational scale, which is, I don't even know how we managed to do it. It's by sheer effort and frustration of a lot of data engineers. So even though I put this beautifully drawn diagram for you here, the reality is even worse than that. The reason that the previous paradigms and the technology that has been created for them is simply not incentivized to give access to data with open standards that respect privacy, that respect security, while they respect open standards, while they enable collaboration and innovation. So what has happened is that we've built something like this beautifully depicted Flemish painting of Tower of Babel. I don't know if you're familiar with this story, but the story of Tower of Babel was that people had this, audacious plans of building this tower to reach the heavens, but the people that were in the city and building this city didn't speak the same language. So that's what they have, an architecture that is barely hanging together. And it's the same with the state of data sharing today. We have an architecture of confused tongues and language because of those lack of incentives for building truly analytical data sharing, APIs that allow you to train your machine learning model on distributed sets of data or doing reports on distributed sets of data. What we have ended up with is a set of band-aids, custom build connectors that go into the guts of Salesforce, CRMs, and many other different applications to expose data that wasn't designed to be exposed for analytics. So there's no intentional, responsible data sharing so that we can build a city that pieces of it actually, speak the same language. So given these challenges, data mesh sets to solve the problem of scale for managing, accessing data for analytics. Again, transactional data, we have addressed this in a way with our API revolution, right? In the mid-2010s, we addressed that with this idea of microservices and standard interfaces. We gathered and we created some open standards around it. This is the next frontier of data sharing, and that's for analytics. So data mesh embraces complexity and tries to address what are just those three problems that I described: centralization, siloing, and pipelines, with a new model. The first and foremost, data mesh acknowledges that to get value from data, we have to go beyond organizational boundaries, whether that's a small team responsible for a particular business outcome, small digital cross-functional team, or it's a whole organization that lives somewhere else in a different, perhaps even country. We have to give ownership and responsibility of data for analytics back to people who are best suited to do that, closest to the data. Well, the data might be the source coming from the application, aligned with the source of data might be an aggregate downstream. So we embrace this domain-oriented within an organization, a domain-oriented ownership of the data by cross-functional teams. And if your organization is an advanced digital organization that has had domain-oriented teams already, they had cross-function, they had embraced this idea of two pizza teams or technology teams that are long-standing, working closely with business toward the business outcome with the digital application. This is just an extension of that, an extension to say, well, we need to bring yet another wall down, the wall between the data and the software, and bring data closer, the responsibility for data and analytics closer to those teams where the action actually happens. The second problem with long lead time from data to value is solved by this idea of data as a product, by localizing the small piece of the pipeline, the domain-oriented data storage and data access, the metadata that makes that data understandable, trustworthy, all of that localized and encapsulated around particular domain concepts. So for example, if you are in a team that is responsible to manage orders, you probably have a set of applications that are, or microservices that are responsible for order management. The extension of that application, let's say that application is this green app with its database, that application will have one or many, depending on how you design it. And I know one of the questions always is like, how do I design the boundary of my data product? So we can talk to that in Q&A. You design one or multiple data products that show, that give access to historical, temporal view of all the orders by all of the customers across all of the touch points. And that is a data that can deliver some value from analytics point of view. And not only that, that data product is designed with the data user in mind. So it provides APIs that are designed for accessing and doing analytics on that data, whether it's a SQL or file feature access, or something else, or something that allows you to run your computation on the, data user run the computation on the data. And it provides all the other information that makes the data usable and discoverable. It's not just the data, it's not just the pipeline, it's also policies that should govern that data. How long should we, what's the retention policy around it? What's the quality policies and the metadata. So everything that's needed. So what we're doing is we are removing that long data to value pipeline. We're breaking it up. We're localizing it around domains. We put a boundary around it. We call it a data product. And we're, every one of these products are valuable and can be now directly used. They don't need to be, the data user doesn't need to go to a middleman to use them. So we're reducing that long lead time to value. And finally, we talked about the APIs for data access and as well. So if you kind of extrapolate from this image of distributed data sharing owned by cross-functional team, removed middleman bottlenecks, we arrive at these 4 principles. And I quickly go through some of these principles, and just not all, actually all of these principles, and give you a little taste of what it is. The main driver for data mesh, again, remember, it was managing kind of organizational complexity and embracing it. It embraced complexity and chaos. And we said, we've seen this done before. We've seen this done in 2003 timeframe by the work of Eric Evans on domain-driven design. We've seen how we tackled complexity at the heart of software with focusing on business domains and giving people autonomy, building applications for those domains. We're going to do the same thing for data. So what does it look like? Well, it would look like this. You have multiple domains. You will have, order management domain. You will have your customer domain. You will have all of these business functions. If you look at how do you discover these domains, you look at your business and you see who are the business stakeholders, how business has organized itself, and technology naturally organizes with that. So you have this tech kind of business-oriented teams, and they have a set of responsibility today. They probably have, a set of operational responsibilities that either, expose some APIs to interact with that business unit, or applications or UIs, whatever these digital touch points are. Now there's a new set of responsibilities for sharing the information for analytical data usage. And the data sharing can be done as a graph, in a graph or in a mesh topology, right? Here I'm putting an example of a digital streaming applicant domain. Let's say we are Spotify or we're, Apple Media, and or SoundCloud or any of these organizations, and we have a responsibility to, a business unit that takes care of podcasts, all the activities around podcasts, and make sure we have best quality podcasts reaching the right listeners and with increased listenership. Well, one of those operational capabilities that this team provides and implements is releasing podcast episodes. And that I'll show that with this O notation lollipop. Well, in addition to that, now this cross-functional team, of course, empowered, providing analytical interfaces, providing data around, okay, what are the top daily podcasts, or what are the top podcasts that people listen to? As an example, this is analysis done on the data, or what are all the podcasts that all the listeners do, and allow the users to do more further analysis. How do they do that? Well, in every domain, there is a set of applications. They might be modern application, might be microservices, might be more SaaS applications, and custom kind of off-the-shelf applications. So it depends. We have a set of applications. Their job is running the business. In this particular case, you have your green domain having a subscription application, subscribing listeners. And in your purple domain, you have that podcast service releasing podcast. And now you have this chain of data products, chain of computation and data and interfaces that generates this analytical data. So in this case, we have information about all of the subscriptions as a data product, information about, listeners' demographics as a data product. And in the purple case, we want to now generate podcast demographics, like demographics of people that are listening to the podcast. Well, podcast domain knows about who's listening to the podcast. So they have podcast events, so podcasts as a data product. And now they consume data about listeners' demographics and doing some analysis, and now generating podcast demographics as a new data product. They probably use it themselves for kind of understanding what podcasts are popular, what are not, to, promoting the popular ones and maybe demoting the ones, or the other way around, give more visibility to the podcasts that haven't been reached, and so on. Perhaps they share that with the rest of the organization. They share that with, the folks, another domain that might be responsible for onboarding artists and content generators and these podcasters, so that they know what podcast people are eager to listen to, or maybe what areas we don't have coverage, right? This data can be used. That's a data-oriented organization, that they can use this data in many other scenarios to improve the business. So then what does this kind of structure looks like in terms of domain? Well, the domain is really a combination of teams, systems, data products now, working all towards a particular mission within the business. For operational APIs, we had GraphQL, REST, gRPC. There are many other protocols for accessing transactional data. A lot of reads or small writes that happens on those APIs. And now we have API for analytical data. Probably many writes and large writes, right? Maybe a small number of reads, but large number of reads. And you want to design these APIs that they encapsulate not only let me access to the data, but they encapsulate discovery of this data product, discovery of how they can get access to it, and access control imposed on those APIs, and so on. So what is this? Let's double click a little bit into the data as a product. The reason I created this second pillar was that if you think about this idea of, well, different organizational units, different domains, own their data, analytics, and there's no centralized team, there's this fear and there is this challenge around, well, we're going to go back to the data siloing of applications today. What is incentivizing these domains, the podcast domain, to nicely and cleanly share their data, share their Topcast podcast listeners or whatever that data is with the rest of the organization. And this is the data as a product is a tool to address that channel. The intention behind it is to really change our relationship with data. Right now, our relationship is data is an asset. I gather it, I collect it, I keep it. I don't share my assets with anyone. I don't know about you. We're not incentivized to share. We're incentivized to collect more. So we want to change that relationship. We say data is a product. There are users that are interested in this product. They get value from this product. As a source, as a providers, our job is to turn that, to delight them, to give them what they need, to focus on the consumers first, and maintain this product long term. It's not something that we dump on an event queue and somebody else is responsible downstream. No. We are responsible for this data to be used as in a target use case and application. And the moment we publish this data now as a data product, we are responsible for it, for its lifetime, right? Unless we say, okay, we'll gracefully retire this. This is a obsolete data and we're retiring it, and we contact consumers and we remove slowly access to it. So it's a very different mentality than data as asset. And often I convey product thinking around the data by these characteristics, by these baseline usability characteristics, that if you think about the journey of your consumers, I'm right now building a product myself. So I'm going through this, but just building, kind of infrastructure as a product. The very first thing you learn when you build a product is think about the life cycle of your data users. How do they discover it? How do they understand? How do they get access to it? How do they get access to it in a secure, privacy respecting way? How do they interconnect it with other data products? How do they trust it? Do they all want to use the data product in the same way? Do they all want to run SQL? Probably not. As you can imagine, we have kind of the analyst brain that likes to access the data with SQL, and no matter what problem you give them, they will type a SQL for you, even if you don't understand what it is and can't maintain it. And you have like more data scientists and a programmer brain that they see world in this more imperative programming model, and less declarative, more imperative, and they want to write code. So they do not, not all of your data users wants to use this product in the same way. So we've got to provide it in a multimodal access, native for these users. And of course, this data has to provide some value, right? It can't be just a normalized table that's joining things. It has to actually have material value and information that can be used. So that's, if you put yourself in the journey of discovery full life cycle of your product, you at least have to provide those capabilities for each of these data products. And then the question would be, okay, how do we even do that? Like, what is in this data product? Is data product is a table of data with some metadata in catalog? Is that what it is? I don't think so. I don't think that's enough. I think the data product needs to have all of the structural components that's needed in itself, because we're talking about a distributed architecture, a decentralized model of sharing in itself, so that it is discoverable, accessible, is lively. And those structural components, in my mind, they fall into these three categories. Every data product should have code in it. It's an executable, programmable unit. Why? Because data is a result of a process. Whether the process is as simple transformation, a simple aggregation, right, over your transactions to show that temporal view and aggregated view, or it's a generative machine learning model that is creating new insights in terms of categorizations, classifications, predictions. There is code always associated with the data. And that's the only way we can solve this problem of data is stale. We don't trust the data because you have something with agency running, keeping this data alive, making sure there is programmable access to this data, making sure there is code that's executing the policies at the time of read and write and access. all of that, from my perspective, from a distributed thinking perspective, has to be embedded in the data product. Of course, the data itself, data and metadata, we want to, and the data and metadata fall into many different categories. The model of the data, semantically, how do we model this data? What does this data mean? What information does it convey? What relationship this information has with other data products? That's your semantic model. And also documentations around the syntax. In what encoding can you get access to this semantic? Can you get access to it through tables and rows? Can you get access to it as events? Can you get access to it as columnars and files and features? So that's a syntactic representation of the data. There's the SLO, how often this data gets updated. When was the last time it got updated? So this real-time information about the data that bridge a gap between what I know about the data, what I don't know, and I can now trust it, and I can trust that this is usable for my use case. So there's a ton of, kind of metadata that goes along with the data to make it usable. And of course, this unit, this code and data unit, needs to exist somewhere, right? It needs some resources. It needs storage. It needs computation. It needs access to an identity system. And all of that needs to be explained, needs to be described so that we can host it in an environment. And we want to describe it in a portable way. Again, we want to move to a future that we're not locked up by the platforms that are storing the data. We want to have some form of control put back into the hands of data generators, independent of the technology that they use. So then you need to have an interface to describe your dependencies to the environment. Is there technology to do that? Probably not. You have to build a lot of this stuff yourself right now, but hopefully it will. So then the question is, okay, yeah, so what is the technology that I need to be able to have this mesh of interconnected data products that are self-discoverable, they take care of code and data at the same time? How is it even possible for my domain teams to not only build applications, but now build and use data products, the sophisticated ML-driven data products, or more simplified data products? And that's the third pillar of the database, the data mesh, that tries to address this concern. So, well, we've got to rethink our self-serve infrastructure, our self-serve platform that lets users to use the data producers on one hand, to create, connect, share data, data users on the other hand, discover, learn, use data. And that's this new model of kind of platform. Platforms in general, what they mean is their purpose is, no matter what platform we're talking about, is abstracting technical complexity so that your domain teams can have a small, kind of a lower cognitive load to do their job. So in the case of data mesh, or in case of data in general, is about removing complexity around cross-cutting concerns that are not domain specific. They're not specific to business logic or business data model. They're just cross-functional concerns like storage, like compute. Be able to abstract that and put that behind a series of APIs again that gives easy access to the users without really worrying about provisioning the infrastructure and maintaining it, without really understanding even how that infrastructure might necessarily underneath scale or work. They just need a clear interface to that piece of infrastructure. And of course, we're all very familiar with this when it comes to these utilities such as the storage, like, BigQuery has an API, S3 has an API. I mean, every resource we use today is essentially a self-serve. It's designed, if it's well designed, it is a self-serve data platform. But what we're talking about here is creating somewhat new layers and new experiences for these data product users and consumers. So we've got the utility down the bottom. We have that today. We have storage, we have processing. Some technologies combine the two, some technologies separate the two. But now we need a set of technologies that really work on this unit of data product. So you can just introduce this language and say, oh, I want to create a data product. And the technology allows you to do the right thing by only focusing on what matters to you. By only focusing on, okay, I need to model my data in a semantic language. I don't even need to model it in different syntax. That platform should take care of it. I just need to describe where the source is, how I'm sharing this data with what modes, just declaratively, and then write some code, right? Whether it's, again, declarative code with SQL or write some code, more sophisticated code to capture the business logic that translates this internal data that the application has generated to some higher order temporal aggregated data for analytics. The rest, how to build it, how to run it, how to secure access to it, the rest should be done by the platform. You would just describe who can access. You should be able to declaratively describe your policies, and the platform should take care of it. And that's what I call this data product experience plane. But again, we not just work with one data product, like as I showed in previous diagrams, we work with a connection of, connected a mesh of data products to continue to create new types of data products and get value by combining and correlating data across many of these data products. So we need a set of services, again, self-served by your platform at the mesh, and new experiences for data users, for data providers at the mesh level. And that's, involves searching, discovering, monitoring, looking at lineage, like all of these kind of functionalities that concern itself with multiple data products. So we need to rethink our self-serve infrastructure based on this newly defined concept. This is all great, but how about concerns that fall in the seams between the data products? How about managing level of consistency where it matters? Where does it matter? Where it matters is with policies. How do we make sure that all of these data products defined by different domains, autonomous teams, moving at a different cadence, having a different life cycle, they adhere to the set of policies that are, that are important to an organization? So how do we standardize policy and policy enforcement and governance, right? We call this governance. And how do we do that without creating yet another bottleneck, yet another control bottleneck, right? Someone that sits in the middle and stamps your data products as good data products. So this is the fourth pillar. The fourth pillar of federated computational governance tries to let us have our cake and eat it too, have this federated model of data sharing, but with governance embedded computationally in every single data product and enforced at every point of access, read, write, access, discovery. And this is not a new concept. This is a concept that we had to implement in our application design and governing our applications when we moved from monolithic to distributed, when we moved from perimeter, firewall-based protection to zero trust architecture. These are not new concepts. We just have to re-implement them in the case of data and particularly applied to data products. So the vision that I had introduced and I'm working toward implementing is that, every data product has a piece of code that is, and data that is specific to the domain, but it has a set of functionalities that need to protect that data, that need to make sure the locality is correct, make sure the encryption is done. There's a set of kind of domain agnostic capabilities that need to happen. And what we need to get to is a way of applying these policies in an automated way. If we rely on people, this system will fall apart as enforcers. So then in the architecture, I introduced this concept of a kind of a domain agnostic code as a sidecar, as a library, as an execution engine, that it is sits in the traffic between data in and data out, data write or data read, and it applies all of these computational policies that the data product owners either author and define declaratively with the data product as code, as in versioned, as code, tested as code, or some policies defined globally, authored globally with your kind of mesh level applications, and then pushed to each data products as this through these control APIs. So this is a particular design. It relies on existence of a set of infrastructure and technology that you probably have to hand code today, and hopefully you will have in future. But the idea is to get this policy as code close to the data. And then, you have these policies defined globally or policies defined locally and enforced always locally, defined locally, or some defined locally, some defined globally. Some organizations, even though they're moving toward data mesh, they're still not comfortable giving access to, let individual teams to define access. So the data mesh is, in an essence, a transformation from this centralized ownership to decentralized ownership organizationally. Architecturally, it's moving from a monolithic kind of to distributed architecture, from collecting data to connecting data, so focusing a lot on data connections. Technically, data is moving from like this idea that data is files or tables or streams as a byproduct of some other code that some other person ran and put it in the sink for us to pick up, moving away from this pipeline thinking to data and code as one unit, as a data product. And operationally moving away from this like governance being a central control to a more federated model of governance and computationally embedding policies as code into every data product. And really, as a principle, moving our mindsets from data is an asset or an oil or money or whatever analogies we have used in the past, to really data is a product. Data is useless if somebody can't get to it, can't understand it. So where are we with this? We are, I think you are here. I guess that's an evidence, and I am here. So I guess that's an evidence of, the data mesh really capture the hearts and minds of users. If you look at the data that's out there, if you look at the Google Trends, you will see this really rapid increase in the interest in data mesh. If you look at the adopters, there are a lot of organizations that are adopting data mesh, and that goes beyond the boundary of like public sector or private sector, and it's worldwide. Europe, in fact, I am really, really encouraged by Europeans, Northern Europeans, because you were one of the early people that embraced data mesh. And I always have this question, maybe it's a question you can answer for me in the Q&A, that why Northern Europe? I have some hypothesis around the values that you live by, and more social values, and perhaps GDPR had forced you to really rethink the data. But I would say Europe picked up on this a lot earlier than North America, at least in the kind of the Western Northern Hemisphere. And I'm excited to be talking about it to you here. In terms of communities, we have had a really rapid growth, unparalleled probably to other communities in terms of how quickly the community has grown. There is a data mesh learning, which is hosted and managed by the courageous Scott Herleman, and we are moving that to a foundation to be independently managed very soon. I'm very excited about that. We have meetups, podcasts, newsletters, Slack channel. Feel free to look up data mesh learning and join the community. And of course, the vendors, the technology providers also have been leaning in to provide technology or remove some constraints from the technology that existed to help you, right? So for example, AWS has spent quite a bit of resources on allowing cross-account data sharing, so we can have data sharing across the boundaries. They didn't fundamentally change the technology, still a lake house-based kind of architecture, but at least they're removing some constraints. There are, the federated query engines that have existed for a long time because they had to solve the extracting data from multiple sources problems. They were an ETL, tool for extracting and getting access data from very silos of applications. Now they are changing their kind of theme more toward data mesh and more toward data products. Data catalogs try to give you a view around this idea of domains, around the idea of data products itself. So yeah, so we're seeing some quick features, removing limitations, and hopefully in the next few years, we will see technology that's built natively from ground up for this concept. So I wanted to share with you some of the challenges and some of the anti-patterns that I see as someone who's at the epicenter of this movement. And I frame this as a question that, are we there yet? Okay, we have all this progress and excitement. Well, what is there? Where is it that we want to get to? Well, data mesh by definition, I mean, is a decentralized socio-technical approach in managing and accessing and using data in analytical context in larger scale complex environments, right? Within organization and across the boundaries of organization. So that's the definition. But I am seeing personally some anti-patterns around this. From the socio side, what I'm seeing is that the people, because the responsibility of data for so long has been centralized, and centralized for good reason, right? When something is new and novel, when the knowledge about that new technology is not distributed evenly, we need a specialist. Well, what we're going to do, we have a few specialists, we go and put them in a silo, we centralize them, right? That's the only viable way to make progress. So because we had done that, and because the responsibility around data has been centralized within data team, chief data officer, organizationally, that's where the data mesh movement is happening. So then what happens is a lot of organizations really fail to extend their hand to encourage their counterparts, their app dev teams, the digital teams, to be part of this movement within the organization. So then the data mesh change is a technology initiative within a centralized data team. Maybe we see some improvements in terms of, breaking up the big data monolith with big, hairy data pipelines into smaller pieces. But nevertheless, we're still one centralized organization. It's hell of an exercise, it's spending a lot of money, but it's still contained and limited to a centralized team. So I guess your question might be, okay, how do we rewire this organizational structure so that we can lend a hand and we can work collaboratively? Well, the very first thing is that you kind of start creating new incentives within your digital domain team. This creation of new roles in the digital teams, like data product owner role, to really start aligning the incentives of people with what they need to do. And of course, this is a very fragile topic to really get your head around, because we can also design the wrong metrics and encourage different kind of pathologically damaging behavior. But if we reward the data teams and incentivize the product teams with data product ownership KPIs, such as happiness of data users, the growth of data users, the reduced lead time to access the data, reduced lead time to actually get value. With all of those incentives, I think we can start kind of and empowering, of course, those teams with these new roles, introducing people that understand both tech and data and business data with new roles such as data product owner is a stepping stone. Generally, if I generalize that topic, what we're talking about as inverse conveys maneuver. What we're talking about is really aligning the people in a way that this decentralized domain-oriented technology and architecture emerges from that. So moving, from a centralized data team to rapid creation, easy creation of data products as independent units, managed, its full life cycle managed by domain teams, will kind of start enforcing this distribution of kind of data ownership and distributed data architecture. And finally, I think all of these efforts will not really get us much further if we do not intrinsically motivate people and create empathy in those domain teams for data and data users. How do we create empathy? We create empathy by intrinsically, having a similar need to those data users, right? So if the e-commerce team doesn't know who will use its data product, let's say user interactions or user profiles, and how they're using it and how it's making an impact, no matter how many data product owners we introduce and give them incentives, they're not motivated. But if we close the feedback loop and said, hey, e-commerce team, there are new ways of optimizing your application. This is automated recommendations by ML is a new way, and embedding that data science capability and reducing actually the friction or the friction for generating and training these models. There are ways of doing that, and embed that need within the e-commerce team. Suddenly things will change. Suddenly e-commerce team realizes, oh, I need data about my application, my user interactions. I also need data about the catalog, the products we sell from another team, and that creates this ecosystem kind of data sharing and empathy for data users, because we become one ourselves. So until the data usage is also centralized somewhere else, I don't think we will have the intrinsic motivations to work in this model. That's why these initiatives get localized to a data team. From the techno part of that socio-technical, also there are anti-patterns that I see being created, and that's, I think, is just a natural state of where we are with our technology maturity. Remember that the technology that we have today has been fundamentally built for a different paradigm. So we've had only for a short few years to kind of get our head around what this thing is. Should we even do it? A lot of vendors have been hesitant, like, should we do something about data mesh? And the easiest thing to do is, of course, have the same product, maybe some features added to it. So then what has resulted from lack of maturity of the technology is a set of patterns or data mesh implemented in a limited fashion. So the first one is a single cloud data mesh. So as long as you are on one cloud provider and all of the data that you need is on the same cloud hosting, then yeah, it's easier to do this data sharing, right? We just talked about cross-account data sharing as a feature. However, many of organizations today, intentionally or just by the entropy of architecture, have data in many different platforms, some on-prem, some on multiple clouds. And what we're doing is like constant shoveling of data from one cloud to the next cloud that we partner with. So where we want to get to is a multi-cloud, technology agnostic data sharing, the same thing that we have with our APIs, right? The other anti-pattern is single platform. So a lot of technologies that have been fundamentally built around, proprietary, closed, kind of centralized data hosting. Again, the data warehouses of the world, and they had a reason to do that because their job was manage a large amount of data, in a centralized way. Those technologies also, of course, they talk about data mesh. They give you some facilities around it to have this concept of a virtual, I suppose, some logical data product. But it's data sharing across those platforms is really hard. So I yet to come across organizations that can, large, complex organizations, maybe small organizations, sure, but large and complex organizations that want to embrace data mesh, have a need for data mesh, have those frictions, and yet all agree to put the data in one place. And the last one, and probably the most damaging of all, is this pipeline data mesh. That what we do is we still have app teams doing whatever they want and put their applications on some queue or event queue, application data on some event queue or not in databases, and create some CDCs. We still have pipelines managed by data team. We still have lakes or some variations of that to store data. And then downstream, we're saying, okay, we create some data products and data product ownership, but we're not really removing that functional siloing and long lead time. So there are missing building blocks. This is where my personal focus and my company's focus right now is to really create this end-to-end peer-to-peer data sharing and management of lifecycle. We have a lot of work to do around data APIs that are safe, that result in consistent view of the data in a distributed way. They can share data across platform boundaries, and they can do that securely. And that requires a different generation of data APIs, which is not just about sourcing the data, is about, in fact, sourcing perhaps the computation that needs to run on the data. The integration technologies are difficult, and there are some hard limitations. Some platforms have never imagined that you will have thousands of storage accounts to distribute ownership of data to different teams. They're just literally hard numbers that we will run into. So we want to get to this North Star that, you know, that honestly, I think it's a place of imagination, but as Carl Sagan said, without imagination, we get nowhere. So we have to imagine something. And in the book and in my conversations, I have this hypothetical kind of fictional organization of digital streaming. And what we want to get to is really an organization that is bringing data concerns closer to the technology, closer to the business, create these cross-functional mission-oriented teams, remove friction for finding, using data in a safe, secure way, so it can nurture this data curiosity culture. And for the platform, I mean, on this diagram, what I'm showing you is the domains, their business objective, their applications, and their data products. I'm not showing you any technology, and that's how it should be. The technology really needs to fade into the background and empower people. And we need a model that scales that. To tomorrow, if we have a new business function, well, we have another one of these circles. We don't have a centralized team that we need to scale. To get to these North Star of peer-to-peer limitless kind of data sharing, we need to be able to somehow measure our progress. And I refer to this wonderful book that wasn't written for data, was written for software, was written to show what metrics materially differentiate between high functioning organizations and poor functioning organizations. I'll go back to this book because it's just a lot of good information here. And what this book shows us is that for your organization to function in a high performing way, in this book talks about software delivery. In data mesh, we talk about data product delivery, right? We have a new unit to talk about now. You really need to optimize 4 metrics across 2 categories, across the category of tempo and resiliency. So what does it mean? You've got to, if you are moving toward data mesh, if you want to know whether you're heading to the right direction, using the right technology, or organizing yourself correctly, you should see improvements on the left-hand side in terms of how quickly can you generate data product, how quickly can you get access to data without compromising security, how quickly can you get value from the data, how quickly can you change that data, right? And make that change propagated through the system. And on the other hand, improving your resiliency. How often when you change data, you see failure in your data products, in your pipelines, in your storage, in your data sharing APIs. And is that being reduced? The ratio of change to fail, number of changes to failure. And if the failure happens, well, how quickly can you fix it? What's the mean time to recovery? And I think these are fantastic metrics still applicable to data products. So I think at this point of the conversation, you might say, oh my gosh, Zhamak, we've lost all hope. Yes, there's a lot of interest, but so many problems to solve. But again, I go back to the words of John Adams. Every problem is an opportunity in disguise. and let's get back to work and solve some of these hard problems. Thank you so much for staying with me for an hour and 5 minutes. I stop sharing here and love to hear from you and answer your questions.
Hey, Zhamak, Nino here. Thank you very much for your talk. Very inspiring to hear it from the creator of Data Mesh. In the matter of fact, I just came from a session before this where data mesh was the topic, and we discussed current challenges we see in the data landscape, how to organize data, and then also how data mesh could help there with the 4 principles. And from there, we also got several questions we have for you, and we're really looking forward to get your answers or your view on those. So maybe I will start with some of them or one of them, and then I will turn to the audience and also see what questions we have here. So the first question was actually, we have these decentralized domains which reflect potentially the business domains, and we know that in the business domains we might have different views of the same entity, let's say a customer. And now how can we avoid redundancy in data if we have these different domains with different data products? That was kind of a first question we had.
Yes, so I think I'm going to challenge some of these idealistic views that data will never be copied or data will never be duplicated. We're embracing complexity, but we don't want to compromise integrity. So I do understand the this kind of worries that we have, but we have to rethink the solutions differently. So I just preface, I guess, my answer with that. What we want to embrace is this reality that different business units, for good reason, have different definitions for entities that at a global level might appear to be the same entity. So let me give you an example. And we want to embrace that, in fact. So when we talk about this federated governance, the aspect that probably I didn't talk about much is about what decisions we want to localize to the business domain teams, such as definition of, let's say you're selling shirts and accessories, the definition of a product in different business domain functions of your business is very different if you're a retailer. And I'll give you an example in a minute. So we want to embrace, in this federated governance, we want to embrace the fact that every business unit sees that data differently for good reason. And let's embrace that. Let's give them the power and responsibility to model their data based on, of course, the needs of consumers. This is, again, an external-facing data product. It's not an internal-facing data. Let's model that based on their understanding of the different facets of the product. But also, let's balance that with aspects that falls in the seam that between those data products that need to be standardized. So this federated governance is really focusing on this dynamic equilibrium between what we locally optimize for to allow moving fast and being accountable for something that you can be accountable for, right? The modeling of a product, let's say shirt or pants or accessories, whatever the retailer sells. And also this global standardization, optimizing for what needs to be optimized globally, which is interoperability. So let's go through a particular example product. Let's say you're a retailer. You have a function of design. You design these shirts. You have a function of manufacturing. You build these shirts. You have a function of logistics. You ship these shirts, and a function of sale that sells these shirts. It's the same shirt, but every one of those domains modulate differently. Why? Because they care about different facets of it. So in the past world, we said we do master data management. We put this shirt in under one model that has, embraces all these facets. And that's, honestly, I've never seen it really work because of those centralized kind of frictions. And the source changes fast. So what we're saying is that, okay, you know, in the design, you care about the style, you care about perhaps the fabric, you care about design-oriented aspects of this shirt. Is this a woman's shirt? Is a man's shirt? In terms of manufacturing, you care about the costs of the manufacturing, you care about the raw material of the product, so different facets of the product. In shipping, you care about the container, you keep caring about how many of these products in the same package. So in terms of sales, care about the images associated with these products so you can sell it on the website. These are different models and we want to embrace that. So that's okay. What we want to also implement is that how we correlate, and connect between the design phase to manufacturing, to shipping, to sales, that is the same shirt. And that is the job of productionizing your data based on a set of standards that your organization, as part of your federated kind of group of data products working together as the, you know, as a function of federated governance, to decide what approach are we taking to identify the shirts uniquely, regardless of the domain, so that when we do cross-cutting view of the data, we know, oh, it's the same shirt, it's just different attributes because it belongs to different team. And you know, that's part of the why this data is not a data in a database and it's a data product, because it goes through some transformation. It goes from these internal IDs transformed to some global ID system, some sort of a web-based linking global ID, however you define that global, so that we can make sure that it still points to the same shirt when we correlate it. And there are other more technical, I guess, implementations here as well, that when this shirt information about this shirt goes through one data product to another data product. Let's say we're getting information about this shirt and we're combining that with the trends to styles, to put it in a style group. How do we make sure when the styles data products get information about the shirts, and if information about the shirts change, style changes as well in this distributed world? And that's more of a technical conversation that I've put in the book around the kind of this streaming model between the data products. Streaming not so much as event oriented, but generally subscribing, always knowing when something changes upstream or something being added, keeping the data immutable, keeping time information with the data. So at least you know how these processing times, maybe something changed upstream, we haven't yet picked that up change. At least for data user, connecting these two pieces is evident that these belong to different times. So there's a set of technical constraints that is probably hard to just like wave my arms around and talk about, that we have to build into these data products. So I am very skeptical of these technologies that just give you, I don't know, a layer of viewing your data application database and they call it a data product, because they do not support these kind of engineering principles that we have to put in place to externalize data as a product and enforce a certain type of interconnectivity so that data is always live. So I just pause here. Hopefully that gives you some pointers which direction to go to.
Yes, thank you very much. Definitely, I think that was a great answer to this question, to rather embrace the differences in the data, because that's actually there for a reason. Okay, thank you very much. So I will turn now to the audience. Do we have any questions in the audience? Okay, yeah.
Thank you. Hi, Zhamak. My name is Tanvi. Wanted to ask more about, and I understand a lot of it is what you cannot share today. I'm avid reader of your book, but in terms of the self-serve platform, is that what your startup is going to give us a view on how to build up the technology? I'm part of a big bank, and we are trying to implement data mesh there. And it's, to your point, they're on-prem solutions, they're data warehouses, they're snowflakes, and there's all kind of technologies one can think about. And the biggest challenge is how do you create interoperability and a way to communicate between the platforms before we get onto the paradigm of big cultural mind shift for people to think beyond the data sets, beyond the duplication of the data sets, and think about the data products.
Yeah. Thank you so much for kind and warm words about the book and following my work. I can't share a whole lot, but if you, I guess what I can share is that absolutely these really hard problems that there are not many vendors out there incentivized to solve is what we are set out to do. And data sharing is absolutely part of that. And we really want to be able to codify this concept of a data product that describe and make it so easy for developers. So the very first persona that we are focusing on are developers, because we think that if we build for developers, generalist developers, not specialists, we can enable large organizations to mobilize the largest population of technologies that they have, and they can really bridge that gap between the app and data. So we're kind of targeting that persona to empower them to create these data sharing through data products in a technology agnostic way. We are partnering with design partners at this phase and co-development partners to do POCs and inviting you to be part of building this solution, to listen you from day one. So if you'd like to be part of that discussion, please send me a message on LinkedIn, and hopefully I can help you, and maybe you can help us too in understanding your real needs on the ground.
Oh, very excited. Thank you.
Sure.
Thank you very much. So then I would jump again to one question of our previous session we had. So as I understood, data mesh is rather for like corporations or little bigger companies, not companies with a very small data landscape. And there we rarely start from scratch, right? There is a lot of legacy there. We have like a lot of organizations kind of set in stone as well. Now we come and want to introduce data mesh. How would you say should our approach be? Should it be kind of a big bang approach? Or is it possible to do this stepwise? And if yes, how?
Yes. Martin Fowler has this wonderful quote that I'm paraphrasing. The only thing that a big bang generates is a bang. So definitely not a big bang approach. So I think one thing to know, and I put that in the last chapter of the book, is that we are, as you mentioned, we are talking about an organizational transformation. Whether it's a mid-sized company or large-sized company, it's not necessarily a greenfield startup, right? So they have some legacy, they have structures that exist. So I think the very first thing is an evaluation of, is this right for us? And is this right for us now, right? In terms of where we are in terms of maturity of the practice in itself. And if you say, and I put a self-evaluation tool in the book to really see what are the prerequisites to even get started. And if you look at that and say, yes, we are, there are a couple of things that are really important in that I just mentioned now. There are many facets, but one of them is that you have an organizational sponsorship. Because again, if you have a sponsorship from your VP of data infra or from your CDO, but CTO and CIO and business units are not aligned, it is a hard one. So you've got to have a sponsorship, a fairly high level in the organization. And even the ones that start from the data team, the successful part, the successful ones, the head of data is going out, is reaching to a particular business unit, finding allies, finding a domain within which that they can start. And the units, the organizational units that you want to start small within is still a domain. So if your organization is just generally not domain oriented, if you have a centralized IT with, centralized teams just doing projects, they're not responsible for products, they don't work with the business partners and product owners that are design partners to design, you have a hard time to get started. So I highly encourage to look at that self-evaluation. It's a spider chart that put in to say whether are you going to have a lot of headwinds to get started even, or no, there's some risk, but we can mitigate it. As your question is exactly where to get started, you want to start small with the big picture in mind, right? Big view of, okay, we want to go through this organizational change, but you want to start small. And again, you want to implement an end-to-end implementation. So have your data infrastructure, technology people aligned with a particular business domain, maybe 2, so you can show cross-business data sharing, maybe find 2 domains. Find a use case that goes across these 2. One of them is a producer, one of them is a consumer, perhaps. From that use case, the use case might be just a simple analytics, simple business question we need to answer, or it could be a more sophisticated machine learning model we need to train. And go from that use case and discover data products within these 2 domains, and just do it within that. Within one domain, maybe it's a bigger domain, one domain, multiple teams, or 2 domains if the domains are smaller. And do an end-to-end iteration of use case, working backward to data products, platforms supporting at the same time, building the features that are needed and empowering those developers. Start exploring with that model and pave the path. And once you've done this a few iterations, maybe now extend to another domain and new teams in the other domain and so on. And you start this kind of following this S-curve of innovation adoption, right? You start with exploration, then you scale, and then you maintain and exploit. So definitely an exploratory approach with the big picture in mind, right, is what I do. When we do, for example, in this company right now, we have some POC engagements. We intentionally design these POCs with a thin slice end-to-end, because we really want to show this data collaboration across the teams, and we want to show empowering that and enabling that. So even if it's a thin slice you do, I encourage start with a domain. And domains are a great organic way, unit. It's like a cell that you can kind of rinse and repeat, and then build your platform to scale to a large number of teams. Hopefully that answers you. But the last chapter of the book, I walk you through adoption of data mesh through this S-curve of adoption, and tuning your metrics. I've noticed that a lot of organizations start with, okay, let's do data product generation. Let's hook something in CI/CD pipeline of our app developers, so automatically they generate a data product and generate a lot of it, right? And then that over indexes on producing something that we don't even know how it's going to be used, right? And then we have a lot of data products that are not used. So the KPI that we're looking for is not necessarily a lot of data products. It's probably a number of connections between the data products, right? So the book kind of describes the scenarios and the metrics to use to guide that start small, start business driven, start end-to-end, and scale very quickly.
Okay, thank you very much. Then I will turn back once again to the audience. Do we have another question from the audience? Yeah, sorry, haven't seen you, too bright.
So good afternoon, my name is Christoph. Thanks, first of all, very interesting. I fully get, the value of the domain orientation and in particular the source-oriented data products. Where I'm struggling is, analytics or even traditional BI is about bringing the different products from the different domains together to get additional insights in a lake, in a model, even in a warehouse, wherever. So my question is that still, or can that still be part of a mesh, or is that obsolete somewhen, or is that then again a producer into the mesh, or how do you see that?
Yes, great question. The reason this is a mesh and not a set of data products at the source is exactly that, is that analytics is, as you mentioned, is about cross-cutting and stitching data and finding patterns and discovering information across many sources. So those analytics, again, what I'm challenging is that we're doing analytics to what end? Are these analytics are aligned with a particular domain function? Perhaps they're aligned with sales, perhaps they're aligned with marketing, perhaps they're aligned with, improving operations and manufacturing. So those analytics themselves become data products that are owned long-term by a particular domain. Of course, the domain is empowered with people that understand how to do analytics, how to build data products. So in the book, I introduced kind of 3 classes that when you zoom out to this mesh, you probably see 3 classes of data products. One is, as you mentioned, are these source aligned. The other ones are aggregates. So data products that apply business logic to multiple sources to now create a new insight that is a result of correlation and aggregation. So you have this analytics perhaps a lot of it fall into analytical, fall into aggregated data products. And then you have this consumer focus, like you really focus on one use case to say, okay, we need to have data products around sales for this very specific kind of sales function that we want to improve, or marketing function. Let's say we want to do marketing outreach to a particular segment of our clients. So we have a data product around that. So all of those aggregations also become data products. Then you might say, okay, what is the technology, right? So in the past, I've used warehouse to do this stitching. We've got to start embracing a more federated version of the warehouse naturally. It is still possible, but hard to manage to say, look, at the physical layer, we use the same technology because we can. Remember that single platform. And say at the logical layer, we have these data products in different teams, but physically they're still utilizing a BigQuery-like technology that we get a lot of speed for processing. You may still do that, or you might say, no, in fact, we would use some sort of a federated query engine to do these joins across many different data products. You might have technology optimization reasons for something that might have been done off the mesh in a BI tool to a data product, so that you can collect the data, aggregate it, shape it in the form that you want to do analytics on, and then push the analytics, the actual like BI tool off the mesh using the data mesh. So there are multiple ways of like optimizing the technical or physical layer. But we want to keep this domain-oriented view and analytics. If it's done for a particular business outcome. So we have to see who cares about it, and somebody hopefully will care about it to be the long-term owner of it. I mean, I work with a lot of analyst colleagues and friends, and what their job is to sit in a group and be thrown out. Oh, can you answer this question? Can you answer that question? Like any question that the business wants, they throw to the analyst team. I think though answering those questions, whether it's a dashboard or report, in the case of analysts, it should be part of a digital experience of that function. And hence, the analytics for that should be a data product within that function. So it's probably, from the organizational side, there is a bit of a difference. And I think from the technical side, both physically and logically, we have to think about, is it possible to define these analytical data products, the downstream aggregates, as long-standing data products as well? They adhere to the same policies, to code, to data, the same thing. And then off the mesh, you might have a display, you might have a digital experience, whether it's a UI application or a BI tool that sits on the mesh and uses those aggregates.
Thank you very much. By checking the clock, I see time is flying. So I think that's a good point to come to an end here. Thank you very much for your talk, and also thank you very much for answering our questions. When I look at my notebook, I would still have plenty of them, and I think that most likely I would get awesome answers as well on these. But as a side, time is up, so thanks again, and enjoy the sunny day in San Francisco today. I just checked, it's gonna be a great one. So thank you to have you here, and have a nice day. Thank you.
Thank you very much for hosting me. Thank you for listening and your wonderful questions. Have a great day, everyone.